Yes, I'm audible.
Yes, sir.
Okay.
Yes, sir.
In the last lecture, I have discussed on the sectional continuity. A function f of x is called sectionally continuous or piecewise continuous in any interval a b if it is continuous and has finite left and right limits in every subinterval. Then after I have discussed exponential order. A function f of x is called exponential order as x tends to infinity if limit x tends to infinity e to the power minus ax into f of x is equal to finite quantity. Then I have discussed few examples related with the exponential order. In very first example, I have shown x to the power n is the exponential order as x tends to infinity. And the second example, I have shown the function f of t is equal to e to the power t square is not exponential order as t tends to infinity. Then I have discussed function of class A. Function f of t is said to be class A if it satisfies two conditions. First, it is sectionally continuous over every finite interval in the range t greater than or equal to 0. And second condition, f of t is of exponential order as t tends to infinity. Okay. Then I discussed the transform concept, an improper integral of the form integration from minus infinity to plus infinity, k of st into f of t into dt is called integral transform of the function f of t if it is convergent, and generally it is denoted by f of s or transform of f of t. The function k of s of t appearing in the integrand is called the kernel of the transform. Okay. Then I defined the Laplace transform. The Laplace transform of the function f of t is generally denoted by L of f of t, and it is defined as L of f of t is equal to integration from 0 to infinity e to the power minus st into f of t into dt, or it is also is equal to f of s. Generally, s is again replaced by p also. Means instead of s, you can write p also. Then I discussed on existence of Laplace transform. If a function f of t is function of class A, then definitely Laplace transform of f of t exists. Then I have discussed some standard results. Result number 1, Laplace transform of 1 is always 1 by s. Is very important results. Keep in your mind. Laplace transform of 1 is always equal to 1 by s. Second result, I have proved Laplace transform of e to the power at is equal to 1 upon s minus a. Laplace transform of e to the power at is equal to 1 upon s minus a. If suppose instead of a there is minus a, then Laplace transform of e to the power at becomes e to the power minus at becomes 1 upon s plus a. Okay, 1 upon s plus a. In the third result, I have proved Laplace transform of t to the power n is always equal to factorial n divided by s to the power n plus 1 if s is positive. Today I will discuss on Laplace transform of hyperbolic function. See here, this Laplace transform of hyperbolic cos of et. It is always equal to s divided by s square minus a square. I will try to prove this standard result. Now see here, this one. Laplace transform of hyperbolic cos of at. According to the definition of hyperbolic cos of at, hyperbolic cos of at is always equal to e to the power at plus e to the power minus at divided by 2. It is the definition of hyperbolic cos of at. Just see here, L as it is, hyperbolic cos of at is equal to e to the power at plus e to the power minus at divided by 2. Now 2 is constant, take outside 1 by 2, actually it is 1 by 2. Laplace transform of the first term is a to the power at plus again 1 by 2 common. Laplace transform of the second term e to the power minus at. But in previously I have already proved the Laplace transform of e to the power at is equal to 1 upon s minus a. I have written here 1 upon s minus a plus 1 by 2, it is common here, e to the power minus at. Laplace transform of e to the power minus at is equal to 1 upon s plus a. Now solve this bracket, take the addition of these two, okay, taking cross product, x plus a into 1s plus a plus s minus 1, s minus a into this 1, s minus a divided by here a minus b, and it is a plus b, just like, therefore product is a minus b into a plus b is always equal to a square minus b square. Therefore here s square minus a square. This plus a get cancelled, this minus a, then remaining term will be in the numerator 2s divided by this s square minus a square. Now these 2 get cancelled with these 2. Therefore the final result is here hyperbolic cos of at is equal to s minus s square minus a square. Now similarly, I will try to prove the next standard result, result number 5. Laplace transform of hyperbolic sine of at. Laplace transform of hyperbolic sine of at. See here. Its result is a divided by s square minus a square. Let us prove this one. Laplace transform of hyperbolic sine of at is equal to Laplace transform of, according to the definition of hyperbolic sine. You must have to know the definition of hyperbolic sine. Its value is e to the power at minus e to the power minus at divided by 2. In according to definition of hyperbolic cos of at, e to the power at plus e to the power minus at divided by 2. But according to definition of hyperbolic sine of at is equal to e to the power at minus e to the power minus at divided by 2. Again apply this Laplace transform to each term. This 1 by 2 is common. Laplace transform of e to the power at minus again 1 by 2. Laplace transform of the second term e to the power minus at. Apply the standard results. Laplace transform of e to the power at is 1 by s minus a minus 1 by 2. Again apply the Laplace standard result here. Laplace transform of e to the power minus at is 1 upon s plus a. Now 1 by 2 take the common. Now take its difference, 1 upon s minus a minus 1 upon s plus a. Taking cross multiplication, s plus a minus a plus a divided by again s is multiplication of this s minus a into s plus a becomes s square minus a square. Here this plus s and this minus s get cancelled. The remaining term will be in the numerator a plus a 2a. Okay, divided by the denominator as it is s square minus a square. Again this a cancel with this a. The remaining term will be a divided by s square minus a square. Okay, therefore I have got the standard result. Laplace transform of hyperbolic sine of at is equal to a divided by s square minus a square. You just see you compare it. In the previous case I have got the result Laplace transform of cos of it is equal to s divided by s square minus a square. And here Laplace transform of sine of 80, I have got a divided by s square minus a square. Now see the next one. Now let us see the Laplace transform of trigonometric function sine of 80. In result number 4 and 5, I have proved the Laplace transform of hyperbolic function, hyperbolic cos of 18, hyperbolic sine of 80. Now here I will discuss the Laplace transform of trigonometric function sine of 80. Now Laplace transform of sine of 80 is equal to Laplace transform of the value of sine of 80 is equal to e to the power I80. See here e to the power I80, इसके पहले सिर्फ e to the power 80 था, यहाँ पर e to the power I80 minus e to the power minus I80 divided by 2i. This is the value of sine of 80. Now see here this one. Now 1 by 2i is common. Laplace transform of this numerator e to the power I80 minus e to the power minus I80. Now apply this Laplace transform to each term. 1 by 2i Laplace transform of the first term minus 1 upon 2i Laplace transform of the second term e to the power minus I80. Now according to again the standard results, Laplace transform of e to the power I80 is equal to 1 divided by s minus ia. आपको मालूम है e to the power Laplace transform of e to the power 80 अगर है तो 1 upon s minus a. Now here Laplace transform of e to the power I80, not simply a, e to the power I80. Therefore the result is 1 upon s minus ia minus this 1 upon 2i is common. Again Laplace transform of second term e to the power minus it is equal to 1 upon s plus ia. Okay. Now takes difference of these two one. Here 1 by 2i is common. 1 upon s minus a first term minus 1 upon s plus I is the second term. Take the difference of these two one. By taking its cross product, I will get this result s plus ia minus s plus ia divided by s square. A minus b, a plus b means s square minus I square into a square. Again 1 by 2i as it is. Now here this s cancel with this minus s. In the numerator, the remaining term will be 2ia divided by s square plus a square. See here, this I square is nothing but minus 1. In the denominator, this I square is nothing but minus 1. Therefore, it's minus and this minus become plus. Therefore, here result is s square plus a square. Now this 2i cancel with this 2i. Finally, I have got this result. Laplace transform of sine of 80 is equal to a divided by s square plus a square. Okay. Similarly, I will try to find the Laplace transform of cos of 80. Now see here, this Laplace transform of cos of 80 is equal to s divided by s square plus a square, where s is greater than 0. According to definition of cos of 80, cos of 80 is equal to e to the power I80 plus e to the power minus I80 divided by 2. But in the previous example, the definition of sine of 80 is equal to e to the power I80 minus e to the power minus I80 divided by 2i. ऐसा था. Okay. Now here Laplace transform of cos of 80 is equal to Laplace transform of e to the power I80 plus e to the power minus iat divided by 2. So this is the value of cos of at. Okay. Now apply the Laplace transform to each term. 1 by 2 is common. Laplace transform of first term e to the power iat plus again 1 by 2 is common. Laplace transform of e to the power minus iat. Okay. Now apply the standard result here. Laplace transform of e to the power iat is equal to 1 upon s minus a plus 1 by 2 as it is. Laplace transform of e to the power minus iat is 1 divided by s plus ia. Okay. Now 1 by 2 is common. The remaining term, the first this and second this, take this cross product, s plus I plus s minus I divided by s square minus I square into a square. Again I square is minus 1 minus minus plus here. Here plus ia get cancelled with the minus I. The remaining term is only 2s. Now this 2 cancel with this 2. I have got the final result. Laplace transform of cos of at is equal to s divided by s square plus a square. Now I will discuss one of important theorem, theorem number 2. It is related with the linear property. Okay, linear property, theorem number 2. Now see here, suppose f1 of s and f2 of s, these are the Laplace transform of the two functions. The first function is f1 of t and second function is f2 of t respectively. Okay, means Laplace transform of f1 of t is f1 of s and Laplace transform of f2 of t is f2 of s. Then prove that Laplace transform of c1 into f1 of t plus c2 into f2 of t is equal to c1 into Laplace transform of f1 of t plus c2 Laplace transform of f2 of t, where c1 c2 are any constant. या तो हम इसको ऐसे लिख सकते हैं, it is equal to c1 f1 of s plus c2 f2 of s, ऐसा भी लिख सकते हैं. Okay. Now let us prove this linear property. What is given here? This f1 of s and f2 of s are Laplace transform of first function f1 of t and second function f2 of t respectively. यानी इसको हम नोटेशन में ऐसा लिखेंगे. Therefore Laplace transform of f1 of t is f1 of s and Laplace transform of f2 of t is equal to f2 of s. Okay, it is given. But according to the definition of Laplace transform of f1 of t, it is denoted by f1 of s, is equal to integration from 0 to infinity e to the power minus st. It is the kernel. Okay, now you take that function. Here function is f1 of t, therefore f1 of t into dt. And again Laplace transform of f2 of t, it is equal to f2 of s, is equal to, according to definition, it is limit integration from 0 to infinity e to the power minus st into f2 of t into dt. Okay, I have applied here the definition of Laplace transform. Now Laplace transform of c1 f1 of t plus c2 f2 of t is equal to, again apply the definition of Laplace transform here. देखिए यहाँ पर Laplace transform of f1 of t है तो डायरेक्ट हम ऐसे लिख सकते हैं, 0 to integration from 0 to infinity e to the power minus st into that function. जो भी function है वो यहाँ पे लेना है. Okay, now here function is this one, this bracket में जो लिखा हो पूरा function है यहाँ पर. Therefore according to definition of Laplace transform, it is equal to integration from 0 to infinity e to the power minus st, this kernel is common here, and into that function. जो भी function है वो यहाँ पे लिखना है. Okay, that function is here, this one, c1 f1 of t plus c2 f2 of t into dt. This is according to the definition of that is Laplace transform. See here, in the next step, apply this integral to separate term. 0 to integration from 0 to infinity e to the power minus st into this c1 f1 of t dt plus, again apply this integral to second term, integration from 0 to infinity e to the power minus st into c2 f2 of t dt. Okay, now c1 c2, it is given that c1 c2 any constant, you take c1 outside the integral sign into integration from 0 to infinity e to the power minus st f1 of t dt plus, again here c2 take the common, it is a constant, in c2 into integration from 0 to infinity, actually here I have missed this right to this term e to the power minus st, यहाँ पे लिखना चाहिए e to the power minus st f2 of t into dt. Okay, but this you see here, this is nothing but according to definition of Laplace transform, this is nothing but c1 is equal to c1 into Laplace transform of f1 of t plus c2 here e to the power minus st into f2 of t dt. Therefore, this is nothing but again Laplace transform of f2 of t. So in this way, I have got this standard result, Laplace transform of c1 f1 of t plus c2 f2 of t is equal to c1 Laplace transform of that first function plus c2 into Laplace transform of the second function. Okay, this is one of the important results. यानी बोलने का मतलब अगर c1 c2 वहां पर कांस्टेंट है तो उसको हम बाहर लिख सकते इस तरह. ओके, now we see the next. Now let us discuss the first shifting theorem. It is one of the important theorem. Now see here, if just focus on the statement of this theorem, first shifting theorem. If Laplace transform of f of t is equal to f of s, देखिए इधर Laplace transform of f of t is equal to f of s. अगर एक फंक्शन है उसका Laplace transform f of s ऐसा अगर है तब then prove that Laplace transform of e to the power at into f of t is equal to f of s minus a. यानी अगर एक फंक्शन है f of t, उसका Laplace transform f of s अगर है तो वो फंक्शंस को हम e to the power, वो फंक्शंस को e to the power 80 से मल्टीप्लाई किए तो डेफिनेटली आपको ये रिजल्ट मिलेगा. सी हियर, तो स्टेटमेंट के ऊपर ध्यान दो यहाँ पर. इफ Laplace ट्रांसफॉर्म ऑफ f of t is equal to f of s, then Laplace transform of e to the power at into f of t is equal to f of s minus a. यानी f of t का अगर Laplace ट्रांसफॉर्म मालूम अगर है आपको, उसके साथ e to the power at अगर मल्टीप्लिकेशन में अगर है तो डायरेक्ट आपको रिजल्ट मिलेगा f of s minus a. This is known as the first shifting theorem. Okay, let us prove this theorem. What is given here? Laplace transform of f of t is f of s. It is given. I have written here Laplace transform f of t is equal to f of s. Now apply here the definition of Laplace transform. According to definition of Laplace transform of f of t is equal to integration from 0 to infinity e to the power minus st into that function, this function, okay, into dt. Then now instead of f of t, here I have taken e to the power at into f of t. पहले सिर्फ यहाँ पे f of t था तो हम इसको ऐसे लिखे होते 0 to infinity e to the power minus st into that function. e to the power minus st कॉमन रहेगा, ये कर्नल है ये. अब जो भी फंक्शन है उसके आगे लिखना है. यहाँ पर फंक्शन ये पूरा ब्रैकेट में जो भी है पूरा टोटल फंक्शन है यहाँ पे. Laplace transform of e to the power at into f of t is equal to integration from 0 to infinity e to the power minus st into that function. That function is e to the power at into f of t into dt. Okay. Just wait. Now see here again. Now प्लीज वीडियो ऑफ कीजिए, नेटवर्क प्रॉब्लम आता है, वीडियो ऑफ कीजिए आप। रेडी में सीसी। ओके, Laplace transform of e to the power at f of t is equal to 0 to infinity e to the power minus st into e to the power at f of t into dt. See, now take the multiplication of these two terms. First term e to the power minus st and second term e to the power at. Now its multiplication is e to the power minus s minus a into t into that next function, the f of t, keep as it is. Okay, now you just put s minus a is equal to sub e. Okay, now it becomes integration from 0 to infinity e to the power minus sign as it is. S minus a is nothing but u into this f of t into dt. Now see this one. What is this? Integration from 0 to infinity e to the power minus ut into f of t into dt is nothing but, it is the definition of Laplace transform. Laplace transform of f of t, or this is nothing but a. Okay, f of s लिखते हैं हम जनरली। इट इज, अगर ये ऐसा होता e to the power minus st इंटीग्रेशन फ्रॉम 0 to infinity e to the power minus st into f of t into dt, तो हम लिखते f of s, but instead of s here it is u, therefore it becomes f of u. It becomes f of u. थोड़ा सा वीडियो ऑफ कीजिए, नेटवर्क प्रॉब्लम आ जाता, वीडियो ऑफ कीजिए। रेडी में सी से आप f of u, actually u is nothing but s minus a, therefore the result becomes f of s minus a. Okay, therefore I have got this is one of these standard results, and this is known as the first shifting theorem. What is first shifting theorem? If Laplace transform of f of t is equal to f of s, then Laplace transform of e to the power at into f of t is equal to f of s minus a. Now let us see some exercise related with these theorems or standard results. Now see example number 1 here. In example number 1, find Laplace transform of t to the power n into e to the power at. ये आपको Laplace transform find out करना, ये फंक्शन का, यहाँ पर फंक्शन है t to the power n into e to the power at. हम फर्स्ट शिफ्टिंग थ्योरम में देखे हुए, अकॉर्डिंग टू द first shifting theorem, Laplace transform of e to the power at into f of t is equal to f of s minus a. What is f of s? F of s is the Laplace transform of f of t. Now, therefore, Laplace transform of t to the power n is equal to, now this, I have proved this standard result, we know this result, Laplace transform of t to the power n is always equal to factorial n divided by s raised to n plus 1. This is the standard result. Okay. Now by first shifting theorem, you multiply this tn by e to the power at. It becomes Laplace transform of e to the power at into t to the power n becomes factorial n divided by s minus a to the power n plus 1. Because we know that this one, this result, see here, s को रिप्लेस करना है s माइनस a से, व्हाट एवर a में भी। अब यहाँ पर देखिए a एज इट इज a है यहाँ पर, लेकिन पहले हमको वो पहले फंक्शन का लैप्लास ट्रांसफॉर्म निकालना जरूरी है। लैप्लास ट्रांसफॉर्म ऑफ f ऑफ t f ऑफ s है। अब यहाँ पर वो जो फंक्शन था t टू, जो फंक्शन वहां पर जो ये फंक्शन है वो है t टू द पावर n। लैप्लास ट्रांसफॉर्म ऑफ t टू द पावर n इज इक्वल टू फैक्टोरियल n डिवाइडेड बाय s टू द पावर n plus 1. Okay. Now, therefore, by first shifting theorem, Laplace transform of e to the power at into t to the power n becomes factorial n divided by, now this replace this s by s minus a. अगर a यहाँ पे 5 होता समझो, फॉर एग्जाम्पल 5 इज देयर, e टू द पावर 5t, देन इट बिकम्स s minus 5. यहाँ पे a है यहाँ पर, इसलिए फैक्टोरियल n डिवाइडेड बाय s minus a to the power n plus 1. Okay. Now similarly, you see the second example. Find Laplace transform of t to the power 5 into e to the power 3t. देखिए यहाँ पर. ओके. पहले हम ये फर्स्ट फंक्शन का लैप्लास ट्रांसफॉर्म मालूम कर लेंगे. स्टैंडर्ड रिजल्ट है, अकॉर्डिंग टू द स्टैंडर्ड रिजल्ट लैप्लास ट्रांसफॉर्म ऑफ टी टू द पावर 5. देखिए स्टैंडर्ड रिजल्ट ये है, टी टू द पावर n अगर है तो लैप्लास ट्रांसफॉर्म ऑफ टी टू द पावर n इज फैक्टोरियल n डिवाइडेड बाय s टू द पावर n plus 1. बराबर है. नाउ सी हियर, लैप्लास ट्रांसफॉर्म ऑफ टी टू द पावर 5 इज इक्वल टू 5 फैक्टोरियल, है ना, n यहाँ पे 5 है, 5 फैक्टोरियल डिवाइडेड बाय 5 plus 1 means 6. Now this is the Laplace transform of t to the power 5. Okay. Now again, by using first shifting theorem, Laplace transform of e to the power 3t into that function t to the power 5 is equal to, now see this result, सिर्फ s को आपको s minus a से रिप्लेस करना है. 5 factor as it is. Now s minus a is here 3, therefore s minus 3 raised to 6. 5 फैक्टर का मतलब आपको मालूम है 1 into 2 into 3 into 4 into 5. अगर इसका प्रोडक्ट करेंगे तो आपको रिजल्ट मिलेगा 1/2 डिवाइड बाय s minus 3 raised to 6. ओके. देखिए फिर से एक बार, यहां पर आपको फर्स्ट फंक्शन का लैप्लास ट्रांसफॉर्म निकालना है. फर्स्ट फंक्शन इज t to the power 5. Therefore Laplace transform of t to the power 5 is equal to 5 factorial divided by s to the power 6. अब उसको आपको जो रिक्वायर्ड लैप्लास ट्रांसफॉर्म चाहिए वो चाहिए t to the power 5 into e to the power 3t का. आप लैप्लास ट्रांसफॉर्म ऑफ e to the power 3t into t to the power 5 is equal to, now this 5 factor as it is. Now the replace this s by s minus a. A is here 3, e to the power at, a is here 3, therefore the result becomes 5 factorial divided by s minus 3 raised to 6. That is equal to 120 and 120 divided by s minus 3 raised to 6. Okay. Now see the next example. Now see the example number 3. I will just discuss on example number 3 and 4. In example number 3, it is required to find Laplace transform of e to the power bt into cos of at. अब यहां पर आपको Laplace transform of जो है cos of at का निकालना है. First you find the Laplace transform this cos of at. Laplace transform of cos of at, standard result already I have proved, s divided by s square plus a square. ये standard result आपको मालूम रहना जरूर है, इसके बगैर ये हल आप सॉल्व नहीं कर सकते. Okay. Laplace transform of cos of at is equal to s divided by s square plus a square. Again, by first shifting theorem, Laplace transform of e to the power bt into cos of at. देखिए cos of at के साथ e to the power bt है यहाँ पर, यानी बोलने का मतलब a की वैल्यू यहाँ पर b है. इसके पहले a जैसे यहाँ पे 3 था, है ना, अब यहाँ पर जो है b है. Therefore ये जो रिजल्ट्स मिला हुआ है आपको लैप्लास ट्रांसफॉर्म cos of at का, जहां जहां भी s है उसको s से रिप्लेस करना है s minus a से. ओके. तो s it becomes s minus b divided by this s is replaced by s minus b, therefore it becomes s minus b square plus a square. Okay. Now similarly, see the example number 4. What is example number 4? Laplace transform of sine of 8 is equal to the standard result a divided by s square plus a square. Therefore again, by first shifting theorem, Laplace transform of e to the power bt into sine of 80 is equal to a divided by s minus b its whole square plus a square. सिर्फ जहां जहां भी s है उसको s माइनस a से रिप्लेस करना है। अब लेकिन यहाँ पर a की वैल्यू b है, डोंट कंफ्यूज यार, ओके। a की वैल्यू यहाँ पर b है, देयरफॉर आई हैव रिप्लेस दिस s बाय s माइनस b, देयरफॉर आई गॉट दिस रिजल्ट्स a डिवाइडेड बाय s माइनस b इट्स होल स्क्वायर प्लस a स्क्वायर, okay. Now the next example I will discuss in the next lecture. If you have any difficulty or if you have any query regarding the today's lecture, you can ask me. Okay. I have discussed in this lecture standard results, Laplace transform of cos of at. I have got s divided by, sorry, I discussed the Laplace transform of cos of at, Laplace transform of hyperbolic cos of at is equal to s divided by s square minus a square. Then I discussed Laplace transform of hyperbolic sine of at, Laplace transform of hyperbolic sine of at is equal to a divided by s square minus a square. Then I discussed the Laplace transform of sine of at, trigonometric function. The result is a divided by s square plus a square. Then I discussed the Laplace transform of cos of at. The result is a divided by s square plus a square, means Laplace transform of cos of at is equal to s divided by s square plus a square. Then after I have discussed the linear property. If f1s and f2s with the Laplace transform of two functions f1 of t and f2 of t, then Laplace transform of c1 into f of t plus c2 into f of t is equal to c1 Laplace transform of the first function plus c2 into Laplace transform of the second function. Then I discussed the one important theorem that is known as first shifting theorem. If Laplace transform of f of t is f of s, then Laplace transform of e to the power at into f of t is equal to f of s minus a. Okay. Now in the next lecture, I have discussed few examples related with this theorem. Okay. If you have any doubt, any queries regarding this, you can ask me. 1 minute is remaining. If you have any doubt, you can ask me. ये कोई तो वीडियो चालू रखा है, प्लीज ऑफ योर वीडियो. See who is this one? Redmi C. Okay. ठीक है. कोई आपको if you have any problem?
No, sir.
Okay.
Sir.
Okay.
No, sir.
Okay. Today I will stop here. In the next lecture, I will continue this topic. Okay. Okay.